Hi guys, good morning. It's another lovely Wednesday. I hope we're all doing fine. I hope your day has been going well. Okay, so today we are doing further mathematics and I'm going to be looking at continuation of the last topic we were treating. But before that, I want us to look at something. Okay, so yeah, we are still on the mental math tricks segment. So let's look at what we have for today. Okay, so today I just want you to learn a trick for finding the square of a number ending in 5. Okay, so any number that ends in 5, that's the last digit is 5. There's a trick you can use to find the square of that number very quickly. Okay, so we're going to look at it. How does it work? Okay, so the first thing is step 1, multiply the first digit by itself plus 1. Now what does that mean? Meaning you take the first digit in that number, add 1 to that digit, then whatever answer you get from that, multiply it by the digit itself. That's step 1. Then step 2, put a 25 at the end. So that's all. There are just 2 steps. Let me show you an example. For example, now we have 35 square. You're asked to find 35 square. Instead of you to go through the hassle of doing 35 times 35 and then you use the number multiplication, you can just pick the first digit. In this case, we have 3 as our first digit. So you then do 3 plus 1, which is 4, and then you do 3 times 4. That gives us what? 12. Now, all you need to do is put 25 at the back of 12. That gives you 1, 2, 2, 5. And that's the answer. So it's far easier and faster than the usual multiplication of 35 times 35. So you can see that. Let's take another one. What if it's not a 2-digit number? What do we do? Okay, so we're still on this square of the number ending in 5. You remember the step 1, I remember step 2. So let's look at something else now. So 105 is a 3-digit number, right? Okay, so in this case, you're going to take the first 2 digits. Okay, so you have 10. 1 and 0 gives you 10. So you do 10, then you do 10 plus 1 and you get 11. So then you do 10 times 11 and you get 110. Okay, so now all you now need to do is add 25 to 110. So it becomes 11,025. That's it. It's very easy. It's a very simple trick, and if you get used to it, it will help you when you have very large numbers ending in 5 and then you need to find their squares. Okay, so that's our trick for today. So let's move on to our topic for today. Okay, so let's go. All right, so we're still on Surds. We're still on Surds. I told you in the last class that we've not covered everything that we need to know about Surds. So we're going to do the concluding part of that class today. So I hope you'll be able to understand everything and follow me step by step. So let's look at this. First of all, let's review how to evaluate something like this. So you have to simplify 20 plus root 45 plus root 125 minus 2 root 80. Now, we talked about this and we said to simplify something like this that involves addition, subtraction, and the likes, you need to first put each sword in its, basic form, Okay, so we're going to do that for each of the swords first, then you see if there's any occurring pattern. So let's do that. So we have expression now. Root 20 can be expressed as root 4 times 5. Remember when we are trying to take it back to basic form, we need to look for a perfect square, the highest possible perfect square that we can get out of that number. So for 20, the highest possible perfect square is 4. Okay, so 4 times 5. For 45, the highest possible perfect square is 9. So 9 times 5. For 125, we have 25 times 5. And for 80, we have 16 times 5. Okay, so we can now simplify by removing the perfect squares from underneath the root sign. Okay, so we should have something like this. So square root of 4 times 5 becomes 2 root 5 because square root of 4 is 2. Then 9 times 5, that becomes 3 root 5 because square root of 9 is 3. Then for 25 times 5, square root of 25 is 5, so it becomes 5 root 5. Now for 16 times 5, the square root of 16 is 4, right? But you have a 2 outside already. So 2 times that 4 gives us 8. So 8 root 5. Now, if you look at everything that you can see now, you can see a pattern. The number underneath each square root sign now is 5 at this point. So we call that similar surds, okay? So we are now similar surds. So we can add and subtract similar surds. So let's do that. So let's do the ones with the positive sign first. So 2 plus 3 plus 5 now gives us 10. Okay, so 10 root 5 minus 8 root 5, and 10 minus 8 gives us 2, right? So 10 minus 8 gives us 2, and then we have 2 root 5 as our answer. So this is just a quick review of the basic things that we looked at in the last class. So let's move on. Now, conjugate surds, that's what we're going to start. We have a lot of subtopics to cover today. So let's start with conjugate surds. Now, when you hear the word conjugate for surds, two surds is said to be conjugates if their product gives rise to a rational number. Now, we talked about rational numbers also in the last class, Rational numbers are numbers that are integers or can be expressed as a quotient of integers, okay? So when you have two surds that you multiply these surds together and you notice that that product that you're going to obtain is a rational number, then those surds are conjugate surds. Now, they are usually expressed in a particular form. Let's look at the form that they are expressed in. Now, mathematically, we express them like this: root a plus root b into root a minus root b. Those are, okay, let's continue. Actually, if you multiply this now, you get what? You get root a all square minus root b all square. Now, there's a formula we call difference of two squares in further mathematics. It's called difference of two squares. It states that when you have a square minus b square, or we're just assuming now, a square minus b square is usually equal to a plus b into a minus b. So in this case, root a plus root b into root a minus root b is equal to root a squared minus root b squared. You can also try out the expansion, the normal expansion. That's root a times root a times minus root b times root a, root b times minus root b. But by the time you do that, the two terms in the middle will cancel out. So you can just apply the difference of two squares there. So you have root a squared minus root b squared. Now, root a squared is like saying root a times root a, right? Now, root a times root a is simply a. It's like saying root 2 times root 2. Root 2 times root 2 gives you root 4, right? And root 4 is 2. So when you multiply the roots, number underneath a root by itself, it gives you the number without the roots. In essence, root a times root a is a. So root a squared is a, and root b squared is b. So this should look something like a minus b now. Okay, so now you will notice that in this our final answer a minus b, there is no roots, right? There's no roots. So this is a rational. Of course, when you do the subtraction, it should give you something rational, like a whole number. So these two surds are called conjugate surds. Root a plus root b and root a minus root b are called conjugate surds. Now, in essence, if I ask you to find the conjugate of any expression in surdic form, now all you need to do is check for the sign. If the sign is positive, the conjugate will carry a negative sign. Okay, now if the sign is negative, the conjugate will in essence carry a positive sign. Let's look at some examples. Okay, just follow me, then you will get it. So this is an example. Write the conjugate of the following: root 3 minus root 2 and 2 root 5 plus 3 root 3. Now for number 1, root 3 minus root 2, I already told you that to find the conjugate, all you need to do is identify the sign and then change it. So we have a minus sign there, we're going to change it to plus. So automatically, the conjugate of root 3 minus root 2 is simply root 3 plus root 2. Is as simple as that. Just change the sign, as simple as that. Okay? Now, for the second one, the conjugate of 2 root 5 plus 3 root 3 is, we're going to change the plus sign there to minus, so it becomes 2 root 5 minus 3 root 3. So finding the conjugate of any sort is easy. All you need to do is check the sign. Don't change any of the figures, just change the sign. Okay, just change the sign. So let's look at an example of how these conjugate surds can be applied to make your work easier in a way. So root 3 and 3 root 2 plus 1 into 3 root 2 minus 1. Number 2, 7 root 2 plus 3 root 3 into 7 root 2 minus root 3. Now, from observation, you would notice that the surds in number 1 are conjugate surds. The only difference between the two brackets is that one is plus and one is minus, so they are conjugate surds. The same thing applies for number 2. They are also conjugate surds. So in this case, all you need to do now is go straight and just square each term and subtract. Let's look at what I'm saying. So let's start with the first one. 3 root 2 plus 1 into 3 root 2 minus 1. Now that will simply be 3 root 2 all square minus 1 all square. So you pick each term. Now you know that they're conjugate surds. Okay, they're conjugate. The only difference between them is the sign. Okay, I'm just going to pick the first term, square it, subtract the second term, and square it. Okay, now, so 3 root 2 all square minus 1 all square. So 3 root 2 all square means 3 root 2 times 3 root 2. That gives you 9 times, root 2 times root 2 is, 2. We said that already. So 9 times 2 will give us 18. And then 1 square means 1 times 1. That will give us 1. So 18 minus 1 just gives us a simple answer of 17. So you can see you started with two surds, two surdic expressions. And all of a sudden your final answer is 17. That's a rational number. So those surds are called conjugate surds. Okay? Now let's look at the second one. 7 root 2 plus root 3 into 7 root 2 minus root 3. Also in this case, you can conclude that they are conjugate surds. So all you need to do is take each term and square each term, then subtract. So we're going to do 7 root 2 all square minus root 3 all square. Okay, now 7 root 2 all square means 7 root 2 times 7 root 2. We've done multiplication in the last class. So 7 root 2 times 7 root 2 is, 7 times 7 is 49. Root 2 times root 2 is 2. Okay, so that gives us 49 times 2, which is 98. And now root 3 square simply means root 3 times root 3, which we've established would give us 3. Okay, so 98 minus 3 is now 95. Okay, so just for conjugate surds, the major difference between the surds is that one would be positive and one would be negative. That's all. Then once you're able to identify that these numbers, these surds have been given to me to multiply are conjugates in nature, then all you need to do is take the first term, square it, and subtract. Take the second term, square it, and subtract. That's all. That's all for conjugate surds. Okay. Rationalizing the denominator. Now let's talk about rationalizing the denominator. Now from the word rationalizing, it means we're trying to make it rational, right? We're trying to make something rational. Okay. Now let's talk about why we need to rationalize. Now we rationalize surds to make division less cumbersome. Okay. Let's assume okay, let me show you something. So mathematically, now A over root B, this is an explanation of how to rationalize A over root B. But let's start from A over root B. If I ask you to divide A by root B, and B is not, root B is not a rational number, it will be very, very difficult because, most times your root B could be 1.59762198. Now let's assume you want to do that without using the calculator. That would be very, 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 very difficult. Okay, so rationalizing helps you to make the division easier. Now, how does it work? You take that expression you've been given that has a root underneath, and then you multiply both the numerator and the denominator by that same root. Okay, so we have A over root B now. So we pick root B, okay, and then we take root B and we use root B to multiply both the numerator and the denominator. Okay, so by the time you do that, you would have A root B over, now root B times root B is what? B. We've established that. Okay, so A root B over B. So that's just, you don't need to start trying to maybe learn, it's not a formula or anything, it's just a way to explain to you. By the time I give you some examples now, you see how easy it is. So look at this example. Okay, so you're given that root 3 equals 1.732. Now you're asked to evaluate 6 over root 3. Now I know you're thinking, oh, I can just use a calculator and do 6 divided by root 3 and I'll easily get my answer. Yeah, but what if you're writing an exam and then you're not to use a calculator and you want to test your mental prowess? What do you do in that case? Okay, so in that case you need to rationalize. Okay, so in this case now we're going to do 6 over root 3 and then rationalize by taking root 3 and using that root 3 to now multiply the numerator and the denominator. Okay? So that will leave us with the rational number as the denominator. All right? So 6 over root 3 times root 3 over root 3 now. So 6 times root 3, of course, gives us 6 root 3, and root 3 times root 3 gives us what? 3. Okay? So 6 root 3 over 3. Of course, we know that 3 and 6 would be 2. Okay? 3 can, you can get 3 from 6 2 times. So 3 and 6 is 2. So 2 root 3. That's our answer. Now, this is much easier to evaluate than 6 divided by 1.732. Okay? So now, 2 root 3 simply means 2 times root 3. And we're told that root 3 is 1.732. So 2 times root 3 just becomes 2 times 1.732, which we can easily now solve. Okay? So by the time we do that, we should get our answer as 3.464. Okay? So that's that for this expression. Now, what about when we want to rationalize surds that have more than one, you have more than one number under the root sign as the denominator? What do you do? Let's see. For surds with denominators of the form root a plus root b now, or root a minus root b, or something bigger, or something more similar to this, how do we rationalize? We rationalize these surds by multiplying with now not just the denominator exactly, but the conjugates. Now you see the difference between the last one and this one. In that other one, we just have one number underneath the square root sign as the denominator, and then we just pick that same thing and we use it to rationalize. But now we are faced with expressions that have, surds in the form root a plus root b, or root a minus root b, and so on. How do we now rationalize these expressions? Now, we're not just going to pick the denominator and use the denominator that way. No, we're going to pick the conjugate. We talked about conjugate, meaning just change the sign. So I'm going to pick the conjugate of that denominator and use it to rationalize. Why is that? Why? Why are we using the conjugate? Why are we not using the same number? Think about it for a second. Why are we using the conjugate of the denominator? Now, we are using the conjugate of the denominator because when we multiply two surds that are conjugate, they give us a rational number. Remember that we're trying to rationalize the denominator. We're trying to rationalize, right? So we need to be looking for something that will give us a rational number. But we know that when I multiply two conjugate surds, I'm going to get the rational number. Wow! So all I need to do is take the conjugate of the denominator and use it to multiply. But whatever you do to the numerator, you must do to the denominator. Balance is very important. Okay, so let's look at this. So this is an example. Express 4 root 5 plus 3 root 2 over 7 root 2 plus 2 root 5 in the form p plus q root r, where p, q, and r are rational numbers. So how do we solve this? Okay, let's start it together. So first of all, let's put our expression here. Now, remember what I said, we'll look at the denominator. The denominator here is 7 root 2 plus 2 root 5. Then we ask ourselves, what is the conjugate of this denominator? Of course, all you need to do is change the sign. So the conjugate is 7 root 2 minus 2 root 5. So what you now need to do is take 7 root 2 minus 2 root 5 and use it to multiply numerator and denominator. I hope you're following. So let's look at that. So by the time we multiply, let's just leave the numerator as it is. We put the two terms in the numerator together. But you know that for the denominators, they are conjugate surds, so we can apply the method for conjugate surds. We square each term and subtract. So 7 root 2 all square minus 2 root 5 all square. Okay, so let's simplify this further now. Okay, just take it step by step. Now, so first of all, to get the answer that to get the next answer that has just been reviewed, what you need to do is first take 4 root 5 and use it to multiply 7 root 2. Okay, 4 root 5 times 7 root 2. Now, 4 times 7 is what? 28. And root 5 times root 2 is root 10. So that's how we got 28 root 10 in the first position there. The next thing is you take 4 root 5 now and use it to multiply 2 minus, take note of the sign, minus 2 root 5. So 4 times minus 2, okay, gives us minus 8. Now, Just keep that somewhere, minus 8. Now, root 5 times root 5 gives us 5, okay, 5. So minus 8 times 5 is minus 40. So that's how we get the minus 40 that is in the next position there. Now, the next thing is we take 3 root 2 and use 3 root 2 now to multiply 7 root 2. Okay, 3 times 7 is 21, and of course, root 2 times root 2 is 2. 21 times 2 is 42, so plus 42 there. Then the last thing is you take 3 root 2 now and use it to multiply minus 2 root 5. Okay, if the sign is positive, you know you can ignore, but when you have a minus, you have to take note of the sign. So 3 root 2 times 2 minus 2 root 5. So 3 times minus 2 gives us minus 6, and root 2 times root 5 gives us root 10. Now for the denominators, 7, for the denominator 7 root 2 square, I mean 7 root 2 times 7 root 2. Okay, so 7 times 7 is what? 49. Root 2 times root 2 is what? 2. So 49 times 2 gives us 98. Then 2 root 5 all square, 2 root 5 times 2 root 5. 2 times 2 is what? 4. Root 5 times root 5 is 5, and 4 times 5 will give us 20. Okay, so we are going to have 98 minus 20 as the denominator. Okay, so just follow me. Now we can collect like terms, you know, for the numerator, we can collect like terms. So we have, you know, 28 root 10 minus 6 root 10. Take note of the signs. You know, the 6 root 10 carries a minus sign. So then minus 40 plus 42 over 98 minus 20. Okay, so what do we have here? 28 minus 6 is what? 22 root 10. Now minus 40 plus 42 is plus 2. So 22 root 10 plus 2 over 78. 98 minus 20 is 78. So that's how we got 78 there. So you can rewrite this now as 2. Okay, now we know that we could have just stopped here, but we can't, because there's a specific form that you are asked to express your answer in, which is P plus Q root R. So now we can rearrange to 2 plus 22 root 10 over 78. Then we separate. So 2 over 78 plus 22 root 10 over 78. You can see that if we do that, we are splitting the terms into 2 parts. So 2 over 78 plus 22 root 10 over 78. Now, by the time we divide, we have what? 1 over 39 plus, now 11 over 39 root 10. So we have succeeded in expressing it in that form that was given to us at the start. So if you are asked to find P, for example, P here now is 1 over 39, Q here now is 11 over 39, and R is 10. You can see they are all rational now. Okay, so that is that. So you need to be careful when you're asked to rationalize or simplify. You need to also look out for the form that you were asked to express the number in. Okay, if that is not specified, then just simplify to the simplest possible, simplify to the lowest possible way of expressing it, and then you just move on. Okay, so that's that for rationalizing the denominator. Take note of what we've talked about: conjugate surds and rationalizing the denominator. Now let's move to something else. Now let's move to equality of surds. Equality of surds. Now, 2 surds are equal if and only if what? So let's look at that. Now, given 2 surds, let's analyze. Given 2 surds, P plus root M and Q plus root N. Now, I will say that, okay, these two surds are equal. Okay, we are assuming that they are equal surds. So let's see the conditions that will make them equal. So P plus root M equals Q plus root N. Now, that means that if we take Q, we put the 2 rational numbers together and put the 2 irrational numbers together, it means that P minus Q, right? We're saying, in essence, we're saying that P minus Q must be equal to root N minus root M, right? Okay. Now, there's a slight hitch here in the sense that on the left-hand side, P minus Q are, 2 of them are rational. They're rational numbers. You can see there's no square root sign. Now, but when we get to the right-hand side, they are irrational there. Those are irrational numbers. Now, it's not possible for two numbers, one rational number to be equal to an irrational number. That's not possible. The only way it is possible is if it is zero. Is if it's going to give you a zero, because else that is not a logical expression. So that means that in essence, p minus q must be zero, and root n minus root m must be zero. So now let's come down, let's break it down a little. Now in essence, it means that p must be equal to q, and root n must be equal to root m. That's the meaning. For you to claim that two surds are equal, for them to actually be equal, then P must be equal to Q, and root N must be equal to root M. Now, why are all these things I have just mentioned, why are they important? I'll tell you why. Now, they are important because in a scenario where you're asked to find the square root of a surdic number, you need to make use of equality of surds. You need to make use of this understanding of this concept to now find the square root of a surdic number. I'll give you an example of finding the square root of the number. Now, so let's look at this. Find the square root of 7 plus 2 root 10. You're wondering how is this going to work out? How is this possible? Okay, it's not hard. Just follow me. What you're going to simply do here is, first of all, you're going to make an assumption. You're going to say, let the square roots, of course, it will contain roots. Let the square root be root m plus root n. So you're going to make that assumption first. Now, that means that you're also saying that root m plus root n all square, since it's a square root, all square equals to 7 plus 2 root 10. Okay? Now, if we expand the left-hand side, it means we're saying root n plus root n times root m plus root n. Now, when we do that multiplication and we expand, we're going to have m plus 2 root mn plus n. When we expand that. Now, we will now do a sort of rearrangement, put the two rational numbers together, m and n, put them together, and then plus 2 root mn equals to 7 plus 2 root 10. Now, these first 3 steps are very important, okay? Now, the next thing you're going to do is, like we've said, for two surds to be equal, the rational portion of the first surd must be equal to the rational part of the second surd, and then the irrational portion of the first surd must be equal to the irrational portion of the second surd. So you can see why we had to show that surds and show the concept of equality of surds. So based on that now, it means that m plus n must be equal to 7. Can you see that? So from there we can get an equation. Let's see. So that means that m plus n is equal to 7. It must be equal to 7. If not, these two surds cannot be equal. Then our next compulsory, concept is that mn, this 2 root mn, must be equal to 2 root 10. Okay, follow me. Now, but we know that, okay, 2 is common to both of them, so we can just pick the number underneath the square root sign, okay? So that means that mn now must be equal to 10. Mn must be equal to 10. Okay, mn must be equal to 10. So we have 2 equations. So you can see what equality of surds, what proving that helped us to, find. So we have 2 equations now, and then we can move on. So from equation 1, it's obvious that, m is, if you take n to the other side from equation 1, you take n to the other side, you have 7 minus n. M is equal to 7 minus n. That can be called our equation 3 now, okay? So now the next thing is, just follow me. The next thing is, we're going to put equation 3 now into equation 2. We got equation 3 from equation 1. We're now going to put equation 3 into equation 2. So let's look at that. That becomes, now wherever you see m, you're going to put 7 minus n. So we're going to put 7 minus n into the position for m now. So you have 7 minus n into n equals 10. Okay, now from here we need to expand. So we're going to use n to multiply that bracket on the left. So n times 7 and n times minus n is what we're going to do. So by the time we do that, we'll have 7n minus n squared equals 10. Now, what does this look like? I think it's beginning to look like a quadratic equation. Yeah, it's looking like a quadratic equation already, but we need to put it in the standard form. So we are going to make it, first of all, we're going to multiply it by a minus to get n squared as positive. So we have n squared, or you can say just take, rearrange in a way. So we have n squared minus 7n equals to minus 10 now. Multiplying through by minus 1. So 7n, n squared minus 7n equals minus 10. Then we bring minus 10 to the left-hand side. We have n squared minus 7n plus 10 equals 0. Okay? So we can say that, that is our quadratic equation. So anytime you're finding the square root of a surd, you would always end up with a quadratic equation. Now then you now have to solve. Remember that quadratic equations usually give two roots. And I said it previously that when you find the square root of any number, you must always have two values. Okay? So that's also reflected here. So when we do let's solve this quadratically now. The factors here will be 5, minus 5, and minus 2. Okay, because minus 5 and minus 2 will give you 10 when you multiply, and when you add it will give you minus 7. So that gives us n minus 5 and n minus 2. So by the time we equate each one to 0, we'll get n as 2, and then we'll get n as also 5. We get n as 2 and n as 5. Now, but take note that we also need to find m. And m is 7 minus n. So when n is 2 now, it means n is 7 minus 2, right? 7 minus 2 is what? 5. And then when n is 5 now, okay, from this expression that we have here, that n minus 5 and n minus 2 are equal to 0, you get two values for n, 2 and 5. Okay, now when n is 5 now, m will be 7 minus 5, which is 2. Now you will notice something as we keep on. Now that means that, remember that we assumed that we said at the beginning let the square root be root m plus root n, right? Good. So there are two options for the square root now. Is either our square root is root 5 plus root 2, that's when m is 5 and n is 2, or root 2 plus root 5 when m is 2 and n is 5. Now, but I think it's clear that root 5 plus root 2 is the same thing as root 2 plus root 5. For example, if I say 2 plus 3, the numerical value of 2 plus 3 is the same thing as the numerical value of 3 plus 2. The only thing is the positions of the numbers, right? So I can just simply bring this down to, I can just say 5 plus root 2 twice, because root 5 plus root 2 is the same thing as root 2 plus root 5. So I can just say the square root of 7 plus 2 root 10 is root 5 plus root 2 twice. It's a bit long. That's the thing about, additional mathematics. It might be long, but once you understand the concept, you would just take it little by little, step by step, take it one step at a time, and you'll get your answer. So that's why I tried my best to explain, the concept of equality of surds to you, to make you understand that for two surds to be equal, the rational portion of that first one must be equal to the rational portion of the second one. And the same thing goes for the irrational portion. So once you do that, you get two equations, you manipulate the first one, get a third equation, substitute it into the second one. We're just using substitution method here. Substitute it into the second one, and then you would now derive a quadratic equation, which would be factorizable, which you can easily factorize. And then once you factorize it, you get values for n, two values for n, and you also need to get two values for m. Then you can now put your square roots together. So that's that for equality of surds. Okay, so remember we talked about conjugate surds, which are surds that when you multiply them together give you rational numbers. Then we've talked about rationalizing the denominator, and we've talked about the two cases where you can be asked to rationalize the denominator and to simplify. Then now we've talked about equality of surds and its application to finding the square roots of a surdic expression. So let's move to the last thing we're going to look at, which is equations in irrational forms. Now you've heard about equations in normal forms, linear form, linear equations. quadratic equations, which we've even seen. Now, what about equations, irrational equations, equations in irrational forms? How do you know, how do you take care of these equations? Now, first of all, you need to know the steps involved in solving them. Number one step, isolate the term containing the radical, that's the root sign. Isolate it. Most times, in fact, I will not say most times, try to put it on the left-hand side. Okay, try to put it on the left-hand side. But it doesn't really matter anyway. It's not like you will get it, but try to put it on the left-hand side. So isolate it. Remove every other thing that is rational, remove it, and then put the term with the radical on one side. Then once you've been able to do that, square both sides of the equation, the left side and the right side. Square both sides and keep doing that until you are rid of the root sign. Until you're rid of that root sign, square both sides of the equation. Okay? Then simplify the obtained equation until you find x. Keep simplifying as much as you can until you get the value of x. Let's look at one irrational equation and let's see how to solve it. So solve the equation 2 root. Now the root covers 3x plus 4, then plus x equals to 36. So how do we solve this equation? So remember that, okay, this is our equation. Remember that our step 1 is to isolate the radical. Now the radical there is 2 root 3x plus 4. So we're going to take x to the other side. We want to isolate that term containing the radical. So we're going to take x to the other side. So that becomes 2 root 3x plus 4 equals to 36 minus x now. So we've isolated the radical. Step 2, we're going to square both sides now. Square both sides to get rid of that square root sign. So let's square both sides. So if we square 2 root 3x plus 4, we would also square 36 minus x. So if we square 2 root 3x plus 4, 2 times 2 is 4. Then the root disappears from the 3x plus 4. So you would end up with 4 into, the 2 square is 4, then the root disappears. So 4 into 3x plus 4. Now 36 minus x means, 36 minus x all square means 36 minus x times 36 minus x, right? Okay. Now you know how to expand that, okay? So we're going to expand that. So by the time we expand the right-hand side, we should have 36 times 36 should give us 1296. Then 36 times minus x gives us minus 36x. 36 times another minus x gives us, this is a perfect square, gives us another minus 36x. So altogether that gives us minus 72x. Then minus x times minus x gives us plus x squared. So you should have something like this on the right hand side. You can try, solving it on your own as you're following me. You can try to write it out. So you know what. So now we can also expand the left hand side. So we have 4 times 3x will give us 12x, and 4 times 4 will give us 16. So that is the left hand side, and we have our right hand side. Now we've isolated the radical, we've squared both sides, and we've been able to obtain something that looks like an equation. Now, but this is not the simplest form of that equation, so we need to simplify this equation as much as possible. So let's try to take everything now to the right hand side and leave a 0 on the left. So we have x squared minus 72x. Now 12x comes from the left and becomes minus 12x on the right. Then we have plus 1296, and 16 comes from the left and becomes minus 16 on the right. So by the time we do this, we can rearrange and take the 0 to the right hand side. So we have x squared, now minus 72 minus 12 is minus 84x, and 1296 minus 16 is 1280. Okay? So step by step, one step at a time. If you don't understand anything, you could always go back and re-listen and see if it becomes clearer. Now, this is also another quadratic equation, which I'll just go straight into solving. The factors we're going to use here are 64, minus 64, and minus 20. So we can factorize here now. So we replace minus 64 and minus 20. We replace 84 with those two, and we factorize. So x into x minus 64 minus 20 into x minus 64 equals 0. So by the time we collect the terms, we have x minus 20, and then we pick x, one of the common terms, we have x minus 64 equals 0. Now the next thing is we need to find values for x. Remember that that's the third step. So we've been able to get a quadratic equation. We've used factorization method to simplify. Now let's try to get x. Now, of course, x is 20. X minus 20 will be equated to 0, so x is 20. Then x minus 64 will also be equated to 0, and x will also give us 64. Okay, now there's always a temptation to stop here and to say, okay, I've gotten my answer for x. Okay, x is 20 and 64, and then you just move on. But that can be problematic because whenever we are solving equations in irrational forms, there's something we usually get sometimes, not every time, but sometimes we get a root, an answer in essence, that is an extraneous root, that is not necessarily a solution. Okay, so you need to check. You need to check and be sure and know which one is an extraneous root and which one is the actual solution. Sometimes the two of them or the three of them, as many as you get, would be solutions. Sometimes you'll get one or two that are extraneous roots. So let's check to be sure. So we're going to check. Let's start with 20. So we're going to put 20 back into the equation that we had at the start, and we're going to check. So 2 root 3 times 20 plus 4 plus 20. Let's see. 3 times 20 is 60 plus 4 is 64. So we have 2 root 64 plus 20. Now root 64 is 8. Now 8 times 2 is 16 plus 20. And that gives us 36. Okay, our original question was also, also had 36. So I think 20 is a solution. So 36 is equal to 36, so 20 is a solution, okay? So now, what do we do next? So next, we're now going to check 64. So let's check 64. So we're going to put 64 now in place of x, and then we have 2 root 3 into 64 plus 4 plus 64. Now let's do that, okay? So let's see, 3 times 64, and then plus 4, that should give us 196. So 196 plus 64. Square root of 196 is 14. Okay, so 14 times 2 will give us 28. 28 plus 64 is 92. Now, our question actually had 36 in it, so 92 is not equal to 36. So 64 is an extraneous root, it's not the solution to the equation. So the only solution here is 20. So our answer for x is 20. Okay, so our answer for x is 20. All right, so let's quickly take a summary of everything that we have, looked at. We've looked at, we started with a review of what we did, and then we talked about conjugate surds, how conjugate surds are surds that you multiply together and they give you a rational number. Now, I said if you're asked to find them, all you need to do is change the sign. Okay, now then we moved on and we talked about rationalizing the denominator. And we said, okay, if you want to rationalize the denominator of just, a term underneath a square root sign, all you need to do is take that same term and use it to multiply the numerator and denominator. But if you have two terms underneath the square root sign as the denominator, you need to find the conjugate, and then use it for your rationalization of both numerator and denominator, okay? So that's rationalization. Then we talked about equality of surds. And we said for two surds to be equal, the rational part of this surd must be equal to the rational part of that surd, and the irrational part of this surd must be equal to the irrational part of the other surd. And then we said that is applied when we now want to find the square root of a surdic number. And we took an example on finding the square root, and then we were able to get our answer there. Then we talked about, equations, solving equations in irrational forms. And we said, if you want to solve equations in irrational forms, the first step is to isolate the term with the radical, then square both sides until, there's no square root sign again, and then you can now solve for x. But remember to test, to check, because some of the roots you might get might be extraneous roots that are not necessarily the solution to that irrational equation. Okay, so I know it's been a bit long. I hope you've been able to follow. Remember that if you don't understand anything, you can always go back, replay, and then try to see if it will be clearer to you. Okay, so let's just look at something I want you to do. Okay, so now number one, how quickly can you evaluate 225 square? Remember our mental map trick? How quickly can you evaluate 225 square? Then number two, can you rationalize this? Rationalize the denominator of this expression here and then simplify. So number three, can you find the square root of this number? I know this is a negative, but it doesn't really change much. All you need to do is assume at the start that your square root is root m minus root n. It doesn't change anything in your approach to solving. So can you find the square root of that? And then the fourth thing is you can try to just visit quizzes.com and practice some games on swords. Okay, so that's what I want to try to do all these things, just to see if you really understood what we discussed. Now, if you don't understand something or you're still not clear on a particular thing, or you just have some kind of comment or feedback on anything you want me to explain further or questions, please feel free to leave your questions in the comment section. I'll get back to you and answer them as quickly as I can. Now, remember to like and comment and on the part you love the most and all that, and also you can share to your friends if it will help them. You feel it will help them with this topic. Then also remember to hit subscribe so you can get weekly updates on further mathematics. So I'll see you guys again on another Wednesday, and I hope you have a lovely day. Enjoy the rest of the day and be good. Bye. Don't forget to leave your comments.